Math 2414, Parametric Curves, Video 2, Sketching a Parametric Curve. At the end of the previous video, I said that we would talk about sketching parametric curves in a subsequent video. That would be this one. But this won't be the only one we do it in, but this will be the first. We're going to sketch the following parametric curve. X equals t squared minus 2t, and y equals t plus 1. In a nutshell, we need to plot some points and connect them. But how are we going to get these points? Normally, when you graph manually, you choose values for x, substitute them for y. That's when x was the independent variable. But in this case, the independent variable is t, excuse me. So we're going to select some values for t, calculate both x and y, and then plot those points. Now, what values of t should we select? Well, we're not giving any restrictions on what t should be. So we'll just start with -2. -1, 0, 1, 2, we'll go 3 and 4. And then we'll calculate both the x and the y's. Now, of course, these calculations will be pretty straightforward, so I'm not going to dilly-dally too much with them. Let's start with -2. If we put -2 in for t here, we will get -2 squared minus 2 times -2. But that's 4 plus 4, so we just get 8. Oops, come back here. But what happens when we put in -2 for y? Well, that's easy. We just add 1 to it. -2 plus 1 is -1. In fact, the y column is going to be very easy to complete because all we have to do is add 1 to our t. So why don't we go ahead and do that for all the y's? -1 plus 1 is 0. 0 plus 1 is 1. Got a nice little arithmetic sequence going here. We'll just continue it. But to make sure things don't get out of line, maybe I should draw some, hold on, folks. Maybe I should draw some horizontal lines. Give me a second to pause the video and clean up this table. All right, that's a little bit better. Who am I kidding? That's a lot better. Okay. So as I was saying, the y coordinates are going to be easy to calculate because we just have to add 1 to the t, 1 to the value of the parameter. So -1 plus 1 is 0, 0 plus 1 is 1. And as I was mentioning, this is just an arithmetic sequence that's really easy to continue. Now, what's not as easy to continue is the x's because this is not linear, and so we won't get an arithmetic sequence. But it's just quadratic, so it can't be that bad. All right, putting -1 into here, we'll get 1 plus 2, which is 3. Putting in 0 gives us 0. Putting in 1 gives us 1 minus 2, which is -1. Putting in 2 gives us 4 minus 4, which is also 0. Putting in 3 gives us 9 minus 6, which is 3. And then putting in 4 gives us 16 minus 8, which is 8. All right, and so now the numbers in red represent ordered pairs of the typical form, x comma y. So let's draw a coordinate plane. Wanted that to be in black. I guess it doesn't really matter, but now it's in black. And let's just mark off some marks to plot our points. Our x's go between -1 and 8, so we don't need much room to the left, but we need quite a bit of room to the right. 7, 8. Our y's, however, only go down to -1 and go up to +5. And now let's plot all of our points. Starting with 8, -1, which is about here. And then 3, 0, which is here. And then 0, 1, which is here. And then -1, 2, which is here. 0, 3 is here. 3, 4 is over 3 up 4, so it's here. And then over 8 up 5 is about here. Looks like we get a parabola. I may miss some of these points. That's not too bad. But we don't just get a parabola, we get a parabola that's being drawn out in a particular direction. A couple of comments when you sketch a parametric curve. Number one, it's not a bad idea to label the value of t at any point that you draw. For example, this first point was when t was equal to -2. You can almost think of t as a counting time. T equals -1. T equals 0 was right there. t equals 1, t equals 2, t equals 3, t equals 4. The other thing about drawing a parametric curve, besides labeling some points on it with equally spaced t-values, is to draw what's called the orientation. The orientation is the direction that the curve is traced out as the value of t increases. Since we started at -2, our orientation looks a little something like this. And the way I'll usually draw an orientation is when I have equally spaced points whose t-values are equally spaced, like I do here, then I'll just put an arrow between each consecutive pair of points. That way I can kind of see how fast or slow this object would be traveling if an object were traveling along this apparently parabolic path. I said it was a parabola, but we haven't really confirmed it yet. Looks like a parabola. There's a square there that suggests it's a parabola, but is it really a parabola? So when sketching a parametric curve, come up with some values of t. You may be given the values of t. Substitute them into the functions for both x and y in order. Plot the points in order. Draw the graph from the first t to the last t, and then the orientation on it is the arrows indicating the direction that the curve is traced.